So this is worksheet 2.5, page 2, or just the backside. We got the same type of problems, they're just going to be a little bit trickier. So we're starting with the compound inequality that says x is greater than negative 20 and less than negative 21. We could either start by making it an intersection, or we can start with a number line. I'm going to start with a number line and see what happens. We obviously are going to need a negative 20, negative 21, and some other numbers to give us a frame of reference. Let's start with the left-hand side here. X is greater than negative 20. Well, we know how to do that. We have a round paren opening to the right, because it's greater than. And on the right side, we have x is less than negative 21. So a round paren opening to the left. The problem is that this is written as a single statement, which means we have negative 20 is less than x, and x is less than negative 21. So can we come up with a number that works for this equation? Let's try negative 19. Well, sure, it works for x is greater than negative 20, but it doesn't work for x is less than negative 21. What about negative 22? This time it works for x is less than negative 1, but it doesn't work for x is greater than negative 20. So this statement doesn't work. There are no solutions. In our second problem here, we notice that x isn't by itself. So we're going to need to do a little bit of work before we can write this in different formats. The first thing we notice is that there's a divided by 2. So how do we get rid of that? We're going to multiply everything by 2. You have to remember to multiply all 3 parts by 2. If you forget to do one of them, you're going to end up with a wrong answer. So 1 times 2 is 2. X plus 2 divided by 2 times 2 is just x plus 2. 11 times 2 is 22. We still don't have x by itself. We're going to need to subtract 2 from everything. 2 minus 2 is just 0. X plus 2 minus 2 is just x. 22 minus 2, just 20. Now we've got it in a form that we're used to. We can definitely find values for x that solve this equation. So let's put it right in intersection notation. We know that x is greater than 0 and x is less than 20. We also know that we can take our compound inequality and put it right in set notation. A equals x such that 0 is less than x is less than 20. So we've got 4 done already. All we have to do is the number line. We know we're going to need 0. We know we're going to need 20. We're not going to be able to fit all the numbers in between. So let's just write down 10, negative 10, and 30. Everybody can understand that. The left side here, x is greater than 0. We know how to draw that. X is less than 20. We use a round parentheses, opening left. And because it's a compound inequality and we have an intersection, we're looking for the parts that overlap. So the left side is 0, the right side is 20, and x can be anything in between. Our final interval notation we can do right from here. Our left side is a round paren starting at 0. Our right side ends at 20 with a round paren. And that's our last kind of notation. For these ones, we're going to have to do a little math on each side in order to get x by itself. We don't have to do it all the way across the intersection. We have to treat each side independently. So to get x by itself on this side, we have to subtract 12 from both sides. So we end up with x is greater than or equal to negative 24. We don't subtract 12 on the right hand side while doing this. That's going to be its own problem. We put in our intersection. Now we attack the right hand side. We actually have to add 12 to both sides over here. So we end up with x is less than 24. Now here's a problem we're familiar with. We can write this right away as a compound inequality if we just switch the left side around. Remember to switch the sign so the pointy side keeps at negative 24 and the open side is at x. And then we can join it to the right hand side. So we have negative 24 is less than or equal to x, which is also less than 24. If we want to quickly jot down the set notation, we just say a is equal to x such that negative 24 is less than or equal to x is less than 24. And we can do that because we just stick the compound inequality right inside. So how do we do this on a number line? Well, let's take the left-hand side. We know we're going to need a negative 24. We know we're going to need a 24. We're going to need a 0 somewhere in the middle. So let's start with x is greater than or equal to negative 24. Greater than or equal to means square bracket, opening to the right. X is less than 24 is a round parentheses opening to the left. And intersection means we take the overlapping part. So at negative 24 we have a square bracket. At 24 we have a round paren, and the intersection is everything in the middle. How do we convert this to interval notation? We take the square bracket from the left. The smallest value is negative 24. The biggest value is 24. And we use a round paren on that side. Now we have number line, interval notation, set notation, compound inequality, and a simplified intersection. Alright, our fourth problem. We have another one that's going to require a little bit of work. The left side, pretty easy. Negative 14 plus 2 we can do right off the bat. Negative 12. In the middle, we're going to have to distribute that 3 to get 9x minus 27 plus 3x, and then we add the final 3. On the right side, we just have 12. Now we need to simplify that middle part. Let's keep the negative 12. 9x minus plus 3x equals 12x. Negative 27 plus 3 equals negative 24. And we just keep 12 on the right side. Now we got to get x by itself. So the first thing we're going to do is add 24 to all 3 parts. What we end up with is 12 on the left-hand side, 12x in the middle, and 36 on the right. As a final step, we just divide all 3 of them by 12, and we end up with 1 is less than x is less than 3. Now that's something we can manage. To convert that to intersection, we just say 1 is less than x and x is less than 3. We also already have it in compound notation, so it's really easy to write it in set notation. A equals x such that 1 is less than x is less than 3. Now let's put it on the number line. We know we're going to need a 1 and a 3. Let's put in 2, 0, and negative 1. We know x is going to be greater than 1, so we have a round paren going to the right, and less than 3. And because it's an and, or an intersection, we want the overlapping part. The bottom is 1, the top is 3, and we just fill in the overlap. So now we have everything but interval notation. Using our number line, we just have a left side being a paren with the bottom number is 1. Our highest number is 3, and it ends with a round paren on that side as well. Now we have all 5 notations. We have our number line, interval notation, set notation, compound inequality, and intersection. Here we have another sentence problem. A equals x such that x is not between negative infinity and 0. So we got to think about this one for a second. What does it mean that it's not between negative infinity and 0? What are some things that we should try? Let's just try writing down some numbers. Negative 100. Is that between negative infinity and 0? Yes, it is. So that's not going to work. What about 0 itself? X is not between negative infinity and 0. If we remember from the other side, between does not include things. So if I say it's between 0 and 1, That's greater than 0 and less than 1. That doesn't include 0 and 1. So if I say x is not between negative infinity and 0, 0 is not between those two things because it is one end of it. What about 100? 100 is not between negative infinity and 0. So this also works. So let's draw it on the number line. The bad area is between negative infinity and 0. This is where we don't want to be. So what we have left over is everything from 0 to positive infinity. So the word not means everything else. If it's between negative infinity and 0, that's not where we want to be. So where x is from 0 through positive infinity. So how do we write that? Using interval notation, our left side is at 0, and we know it goes to positive infinity. Can we convert that into a compound inequality? Sure. We know that 0 is less than or equal to x, which is also less than infinity. And just like in previous examples, we don't really need that part. We could just say x is greater than or equal to 0. But let's keep it for now so that we can write an intersection. We can say 0 is less than or equal to x, intersection x is less than infinity. For set notation, we already have it, but we can also just write it as a equals x such that x is greater than or equal to 0. Here's another one written in set notation using just English words. B equals x such that x is greater than infinity. Now here's a problem. How are we going to write this? Can we think of a number that is greater than infinity? I don't think there's anything that is going to make this statement true. So this one, right off the bat, is just going to be no solution. Here's our other number line problem. And as we know, the easiest thing to convert from a number line is to interval notation. So let's do that right off the bat. We're just going to use the square bracket. We know negative 12 is the bottom. And since the right arrow is colored in, we know that it goes all the way to infinity. And we can never get there, so we're going to use a round paren. So what does this mean? Well, every value that is greater than or equal to 12 is shaded in. So we can just write that down. X is greater than or equal to negative 12. if we really, really want to, we can also say that x is less than positive infinity. To write that, we always do it with the smallest value first. So we would flip this around, including the sign, to say negative 12 is less than or equal to x is less than infinity. This part is implied. We don't have to say it. But sometimes, when you're going from one notation to another, it makes things easier or clearer. So since we have our compound inequality, we can use the shorter one over here to make set notation. We'll just say a equals x such that x is greater than or equal to negative 12. If we really want to be pedantic about it, we can write this as an intersection using the big compound notation over here. We can say negative 12 is less than or equal to x, the intersection of x being less than infinity. And that is all 5 of our notations. By now, you guys should be pretty good at switching between the different types of notation. We know that interval notation to number line is pretty easy to do. We're going to need a 0, and we're going to need positive infinity. Let's put in a couple more numbers just to make it clear. The left side is a square bracket at 0. The right side is positive infinity. And we got to fill in everything between. So we can write this pretty easily as all the values of x can be 0 or greater, otherwise known as x is greater than or equal to 0. Just like the last problem, if we want to make a compound inequality out of it, we can switch these around, put the smallest value on the left, less than or equal to x, and the biggest value on the right. We can convert either one of these to set notation. I will use the shorter one. And again, if we really want to force the issue, we can convert this into an intersection notation, just like we've done all the others. 0 is less than or equal to x, intersection x is less than infinity. The last problem on the worksheet is a pretty simple one to figure out. I can't think of any real numbers that don't fall in to negative infinity to positive infinity. Therefore, our solution is all real numbers. On a number line, we still need to put some numbers in here to show exactly what we're doing, but we just color in the whole thing. If we really want to be pedantic, we can write this as a compound inequality. X is greater than negative infinity and less than infinity. And our set notation, we can either write with English words or with that compound inequality. And by now you should be able to convert a compound inequality into an intersection pretty quickly. And that is the end of the worksheet. Feel free to ask Ms. Bacon or myself if you have any questions on these problems.